Hey, Sam here. Let's do another daily Leetcode question together. Hope you're ready. We are doing a medium one today. It's number 2816. Double a number represented as a linked list. So we are getting linked lists. This is exciting. All right, so we're doing, haven't done a linked list in a long time. You don't really see it in work very much, but good to understand. It's very visually pleasing to think about. You're given the head to a linked list, non-empty, no leading zeros, or it's representing a non-negative integer without leading zeros. So the value 189 is the number, integer number 189. Return the head of that linked list after doubling it. So probably in place. So 189 times 2 is 378, so we're returning 378. We could generate a whole new linked list if we wanted to, but here's where it gets interesting. Because I was just thinking, this one is easy, you just double every single value. But what happens when the values double and you have a number that has more digits because you've increased it? And they want you to return that new head. So this makes me think of the question where we had carryover bit for adding two numbers together in a linked list. I think this is similar. Let's think about this. Also, the number of nodes will be 1 to 10,000. This is interesting because I think that means that we could have values that are bigger than the size of an int power 32. So we will probably need to do this in place per node. And the values will be 0 to 9. No leading zeros except for the number 0 itself. All right, let's start coding. Let's see what we can do. Super brute idea was if int fits in memory, convert list to int, double int, new list out. New linked list out. I don't think this is the way an integer would want to do it because it doesn't work if the integer is too big to fit in memory. Also kind of just sidesteps a lot of the issue, the logic in this problem. But good to keep it in mind. Might come back to this at another point. Another idea is to iterate through linked list. If doubled value had same digits, this is trivial, double each value. So that would be great. And I think we need to keep that in mind, that we want to implement this at first, but then we can start thinking about the special case of what happens if more digits needed. A carry bit, as it were, a carry digit, let's call it. Let's start by just going through the array and let's start with the simplest approach. While, or let's say equals head, and head stays the same while cur exists, cur.val times 2, and then we just return head. So that would be the trivial case where it just doubles every digit, every value, and returns the original head because we are just taking that. Oh, and we also need to cur equals cur.next. Sorry. Need that as well. And then if it's empty, none, then it'll break this while loop. It'll keep going until it's done, and then we return the head. This would be fantastic if that's all we'd need for the special test case of, let's say, 189, but it wouldn't work for 999. So how do we deal with what happens when we have a parent equals none for now, let's say, and then if cur.value is greater than or equal to 10, and cur.value equals just modulo 10, get the remainder, and we want to add parent .val plus 1. And that'll just move it up. And is this enough? Because what do we need to keep track of all the list and go backwards again? When you're doing arithmetic, you do have to worry about passing the carryover. Is that true here? So 500 times 2 equals 1000. 999 times 2 equals 1998. I noticed that no matter how big the number is, you only ever get one more digit. And in fact, if this was 499, we'd always get 1998. Oh, sorry, 998. So no matter what the digits are back here, these could all be 9s. If the first digits are 4 or less, it's always going to be fitting in the same number of digits. It's only when it's a 5. And once it's a 5, it's always going to be 5 or greater. Always add 1 to carry parent. And it actually won't ever matter because 9 times 9 is 18. That's the largest possible number you can get. So that's a 1 for the 8. So we only ever add 1. So this should work as is, which is nice. Of course, we need to deal with the special case of what if there's no parent. I kind of want to, there's two ways we can do this. So first, let's just start with if not parent is none, parent equals a new node, list node 1, or let's call it list node 0, and head equals parent, because that's the first one. So now this should actually create a new head, and the parent, of course, needs to have the next being the current parent. And we then add 1 to it in the next loop. Kind of want to do that outside of this while loop, but let's just keep it in here for now. I'd like to see if this will work. Let's try submitting it. Wrong answer. Return 2. What's going on here? Duh, like this needs to be current. Like that. And in fact, we can combine this. And also we need to keep track of incur equals current next. There we go. Let's try submitting this and see how it does. Great, accepted, and falls comfortably in the bell curve a little bit fast too. Beats 95%. Happy to see that. Let's clean up the code a little bit. I do agree it's a little bit messy here, so let's have a look. What I'd like to do differently is kind of pull this out. Head.val grade equal to 5, and then head equals parent. We can keep that there, and then current equals the current new head. I'd like to pull this out of the loop just because it requires less checks within, and then we can have it simplified to the parent will exist. The parent will always exist if it's needed. There we go, and the submit 212 and 19 megabytes. About the same. About as good as we get, so I'm going to say this was a fun question. Hope it was fun for you all as well. See you all next time. Cheers.